Hello, 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 everybody, and welcome back. We're looking at question number 20 on the Grade 8 2008 Gauss Math Contest. What is the area of the figure shown? They're talking about this figure over here. I'm seeing a 5, a 3, a 9, an 11. I'm also noticing that two of the sides are parallel, and that the 3 happens to be the distance between these two sides. Now, it's not quite a parallelogram, because that would mean that we need the other two sides parallel. It sort of brings to mind the idea of a trapezoid. I believe, indeed, we could treat it like a trapezoid. Let me just think about this for a second. So a trapezoid, I'm used to trapezoids looking like this. And, there's an A, there's a B, and you have the height. And what do you do for a trapezoid? You just sort of duplicate it by matching up same side lengths. And then you're left with a parallelogram. Now, this one's sort of skewed off to the side, so I don't think it'll work. Oops. So the long side term. No, I guess it would work. So we could do basic trapezoid work. So what have we got? We know the top of this thing. We know we've got a height of 3. The top is 9. The bottom is 11. So in theory, the area should be 1/2 the two sides times the height, because it's 1/2 of the big parallelogram that you put together. So that's 1/2 9 plus 11 times 3. So that should be 1/2 20 times 3. Half of 60 is 30. So I'm going to say my answer is 30. Is that one of the possibilities? Indeed it is. All right. Now, could we have done this a different way? Absolutely. I mean, you don't have to notice it's a trapezoid, I don't think. I think you could probably break it... Well, I think you could probably break it down. I'll actually do it just to make sure I can. But I think you could chop it up into a section in the middle that's a rectangle and two right-angle triangles. Not everyone remembers the area of a trapezoid. That's okay. Sometimes I forget it as well. I have to remember, you got to flip it and make a parallelogram. And I can recreate the formula if you give me a moment. But, area of a triangle, everyone knows that. Area of a rectangle, everyone knows that. So if you wanted to, and I'm going to do that, let's try and break this one down and do it a slightly different way. Let's break it down into some smaller parts. I think, because we should know the Pythagorean theorem at this point, I think we can do this. So what I'm going to do is I'm going to take that 3, I'm going to make him a height here and a height here. Now, because I've got a 5 here, I've got a right angle triangle, I can figure out this side here. It's the square root of 5 squared minus 3 squared. That's going to end up being 4. Okay, you can verify that with your calculator if you want. And then what's going to happen? Well, this leftover bit with 4 has to add up to 11. So it's got to be 7. And so it's a rectangle. We got a 7 up here. And this leftover bit here has to add up with 7 to be 9. So that's going to be 2. So another way we could do this question is say, well, the area of this right angle triangle is 1/2 base of 2 times height of 3, plus this middle rectangle, which is 3 times 7 for the area, plus this triangle down here at the end, which is 1/2 base of 4 times height of 3. So this is 6 over 2, which is 3, plus 21, plus 4 times 3 is 12, divided by 2 is 6. 3 plus 21 is 24, plus 6. Once again, we get an answer of 30. So, either remember it's a trapezoid or break it down. Two excellent ways to do the question. And I think that is a fantastic way to wrap up question number 20. Did I write down that it was D? I did not. Got to remember to bubble in our answers. But I think that's a great way to end Part B. I hope that Part C has equally good questions. We'll be starting off the 8-mark questions in the next video, so stay tuned for that. And in the meantime, have a wonderful day.